We have been going on and on about IP addresses, but how does one obtain these IP addresses? So that is the focus of this video. But first, the usual recap questions. We have seen earlier that an organization gets an IP prefix. This is the network portion of the address, and then they use the host portion to allocate different addresses to the different hosts that are part of the organization. So the first question we will ask is, how does an organization get an IP prefix that captures this address block? The answer is rather simple. It gets it from whoever it is buying the internet service from. So these are called the internet service providers. So in India, we have Reliance and Tata. At the international level, there is Sprint, AT&T. There are many other players as well. Great, but how do these ISPs get the addresses? Well, for them, there are these entities called Regional Internet Registries, RIRs. There are 5 of these registries spread over the world, which in turn are controlled by this corporation called Internet Corporation for Assigned Names and Numbers, ICANN. Each regional internet registry caters to a specific region. As I mentioned, there are 5 of them. So the black AfriNIC caters to the African region, the red portion caters to Asia Pacific, the blue portion focuses on North America, and the green portion on Latin America and the Caribbean, and the yellow portion on the European region. ICANN manages the entire 32-bit IP address space. Let's go back. So an organization gets an IP prefix from the internet service providers. And an internet service provider follows the same strategy as the CIDR that we have seen before in allocating the address blocks to the individual organizations. For example, if this ISP has this specific block, so it corresponds to this particular IP prefix where the first 18 bits belong to this particular ISP blocks. Now, when it wants to assign addresses to the different organizations that are buying service from this ISP, what it does is it uses some additional bits within this portion to allocate prefixes to the different organizations. For example, it allocated the 0 to this organization 0. Since this is already allocated, the remaining organizations will have 1 in this particular place, and then it is using additional bits to again distinguish the prefixes across the different organizations. These internet service providers will have many routers that manage these organizations as well as interconnect them. These routers, when they advertise to the rest of the world where they are interconnected to other routers belonging to other ISPs, they again depends on the specific situation, often advertise a prefix that is like this. So you're not going to advertise individual organization prefixes. You try to aggregate even here and advertise a prefix that captures this aggregation. This is so that the number of entries the routers have to maintain is further reduced. Now that an organization has an IP prefix, how does a host within this organization get a specific IP address? Note that an organization can have many physical networks, and it can do subnetting based on this particular IP prefix. Now, an address that is allocated to a specific host naturally needs to be unique, and not only that, it has to be location dependent. Based on which subnet it belongs to, it will get a different IP. That means that if this host is now plugged into different subnet, it needs to change its address. This means that these addresses have to be reconfigurable. This is unlike the Ethernet addresses, which are fixed as decided by the Ethernet manufacturer, the card manufacturer. When you're configuring a host, you often need to give it a specific IP address. You also need to give it a mask that specifies what the network portion corresponds to this particular IP address. And often when you are doing this address configuration, you also specify the default router's IP address. You can also specify the DNS server information. We didn't cover DNS, we'll do so sometime later, but you need this information also. So one option is for the system administrator to sit at a host and do this configuration, but this can be rather cumbersome. You want a method of remote configuration. This will ease life. But here is the problem. The way the internet protocols work, for any communication, the host needs an IP address, and especially if it is sending traffic, it also needs the default router's IP address. Without it, you cannot communicate with the host. Now, if you want to do remote configuration, you should be able to reach the host, and without the IP address, you cannot reach the host. So this leads to this proverbial chicken and egg problem. A bit more detail. If you want to do manual configuration, this is how you can do. In Windows, you can do via the control panel, go to network, internet, network connections, local area connections, pull up this TCP IPv4, and there you can set the IP address, net mask, so on and so forth. If you want to do it in Unix, you have ifconfig command that will help you do this. But as I mentioned, this kind of configuration doing remotely is rather difficult. This can also be error prone, especially if a human is involved. He may, for example, assign an IP address corresponding to a different subnet to someone who belongs to another subnet. So the best method forward is automatic configuration, and this is done via this protocol called Dynamic Host Configuration Protocol, DHCP, where a host dynamically gets an address from a server, and this is a plug and play operation. All you need to do is you boot up your computer, enable DHCP, and you get an IP address with all the mask as well as next hop router DNS server information automatically. This is a very desirable feature. The idea is rather simple. So we have a server called the DHCP server that maintains a pool of available addresses. These addresses come from the IP prefix that is assigned to the particular organization. How to allocate to individual subnets we will see shortly, but typically these addresses from this pool are handed out to a host based on demand. That is, they are leased for some specific time. And the hosts periodically need to renew the lease. For example, if you shut down your host, you don't need an IP address, in which case the address that is allocated to you before can be allocated to someone else. But if you want to continue to use the IP address because you are alive, then you have to renew the lease periodically. One biggest advantage of this is the ease of configuration. There is no manual configuration involved. This is automated. Can you think of any other advantage with this particular server approach? Another big advantage with this approach is the reuse of IP addresses. For example, if this organization only has a small pool of IP addresses and lot more hosts, but it is given that any given time the number of hosts that are alive or active is very few, you can reuse the IP address. So this is a bit similar to the statistical multiplexing that we have seen before. Another advantage that this approach gives, which is related to this automated configuration, is that it supports portability. What do I mean by this? Suppose you have a laptop. Now you have taken it from, let's say, the computer science department to the electrical department, which is on a different subnet. Well, if you're going with manual configuration, you will have to go search for where the system administrator is before you can even plug in to the internet in the electrical department, because you wouldn't know what the subnet mask that is being used there is. Not at all desirable. Neither you nor the system administrator will be happy. Overall, the use of a DHCP server that permits automated configuration seems like a great idea, right? But how do you implement it? What are your thoughts? Well, how does the host know the address of the DHCP server? So let me use this occasion to emphasize a specific point. You remember the Bell the cat story? So we have this group of mice debating how to overcome the threat of a cat which is catching mice and eating them up. So one smart mice proposes, let's place a bell around the cat's neck. That way we will know when the cat is coming. And everyone says, what a great idea, wow, deserves a Nobel Prize. Until someone points out who will place the bell on the cat, and then no one volunteers. So what is the lesson to be learned? The idea is great. It achieves the desired outcome, but execution is very important. So going back, how would you execute this idea? Let's take a human analogy. Suppose you need to contact some boy Chotu. You don't know who this person is and there are a lot of people. What do? So what do? You shout out Chotu Chotu loudly so that everyone can listen, and then the concerned person, if he is there, he is going to get back to you. And that is exactly what is done here as well.